Hello and welcome to the video tutorial series on how to set up a proper spatial or non-spatial voice chat using the Unreal Engine and the ODIN Voice chat solution by 4players. My name is Steven and I will guide you through the setup of the ODIN Voice chat in this series. Because we want to focus on the ODIN specific topics, we will start with a simple game that is prepared for local networking. You can find and download it in the description. We will extend it to create a 3D space voice chat with TeamSpeak and a radio set functionality using blueprints only. So in this video I will quickly guide you through the capabilities and use cases of ODIN and its general work-wise before jumping into a rundown on how to set up your environment with a base project and adding and setting up the ODIN plugin. Lastly, we will add simple non-spatial voice chat as a first step. In the next video, we will then look at how to make that spatial. ODIN is a solution for voice chat that allows for both spatial and non-spatial sound, and that is easy to implement and allows for minimum effort to manage and maintain in order to focus on the application's specific requirements. For this to work, it offers your client application a media stream that it can use like any other media. For the Unreal Engine, this means that you can use it in any audio engine that you like, be it the Unreal Audio Engine or any plugin-based one like Steam Audio or Microsoft Audio. Following the same principle, ODIN executes most managing tasks automatically, without your clients needing to communicate much more other than that they want to join a specific chat room. Let us take a look at the base project we are going to use. It is a simple third-person game using the Unreal Engine's networking. When we start the game in the editor, we can see that we are simply able to run around and jump, and that is pretty much it. When we change the startup options of the Play in Editor mode from Players Standalone to Players Listen client, and change the number of instances to 2, and then start the game as usual, we can see a second window and can see the second client when moving around. So this simple networking already works and we just want to add a spatial voice chat to it now. As mentioned in this video, we will first start with a non-spatial audio to show the ODIN plugin in the most condensed down form. The project structure is fairly simple as well. We have some folders for prototyping and some custom logic for the game. The most important folder will be the ODIN content folder, which holds all relevant game-specific assets and blueprints. But first, let us close the project and install ODIN so that we can start adjusting the project. Installing ODIN for Unreal is as easy as searching for it in the Unreal Marketplace to acquire it, and then installing it to the engine version you wish to use for your project. Alternatively, you can go to the GitHub repository. The link is in the video description. There you go to its releases and select the correct downloadable file. Usually, new releases of the ODIN plugin are available here first, but you have to put the plugin into the plugins folder of your engine or of your project manually. Once installed, open the project. If needed, recompile your binaries. This is most likely the case for the source-built Unreal Engine versions. Then go to the plugins menu of the editor. Search for ODIN and make sure that the plugin is enabled. In order to start using ODIN, you first have to create an access key and an access token in order to authenticate with a backend. For testing purposes, you can simply generate a free key that allows for up to 25 concurrent users. This is enough for evaluation or even development purposes, but once you plan to go into production with your application, you should consider creating an account to subscribe to one of the plans or get in touch with the creators, the 4players team, to work on a deal for your use case. Creating a free key can be done in several ways. For this tutorial, we go to the 4players Getting Started documentation page on the web and find a JavaScript widget that does exactly that, and use that static key, for example, as a configuration variable in your project. To use the ODIN plugin now is pretty straightforward and flexible. It exposes the functionality of the voice chat as a static function library, and so you can decide how you want to implement it in your project. Additionally, it offers you an ODIN synth component, which inherits from Unreal's audio synth component and thus gives you access to both ODIN functionality and also integration into your audio engine. These synth components are later used to handle the media streams of other clients in the same room. You could create an actor component, or directly put it, for example, onto your player controller class. While testing and evaluating, we found that creating an actor component for use on the player controller class makes most sense, as it is reusable and creates an abstraction for the voice chat logic that keeps your project tidied up. So this is the approach that we will use for this tutorial as well. So to start creating a simple logic for the voice chat, we will first create an actor component blueprint in the content browser in the ODIN Content Blueprints folder. Directly inherit the blueprint from the actor component class. In the newly opened blueprint editor, we will now start to build a logic that directly connects us when play begins. To possibly change the point in time later, we will create a custom event for that. Name it initOdin and call it from begin play. For better readability of your logic, you may place a sequence node behind the custom event. Now we will create an instance variable to hold our access key. Next, we will create a local room handle. This handle simply holds a reference to the local configuration and all methods related to the connection to ODIN. Create a default APM settings struct and put it in the construct local room handle node before promoting the resulting room to an instance variable for further use. Next, we will create logic that reacts to the different events happening in the lifetime of a client's connection to an ODIN room. These are when the client joins or leaves the room, when another client joins or leaves the room, and when another media stream is added or removed from the room. First, let's take a look at the media added callback. We can fire an event that creates an ODIN synth component and attaches it to the owning player controller. We plan to attach the component we are building to the player controller class. Create an ODIN synth component. Assign the media stream to it and activate it, since it is not auto-activated. For further use, we will also add the synth component to a map that holds the ODIN PIDs as keys. You can change a variable to a map in its details directly next to its type. After changing it, the original variable type is used for the map's keys, and you can define a second type for its values. A map can now quickly return the corresponding value for any key that you give. Every other event also feeds us with a related ODIN PID, and this way we can always find the corresponding ODIN synth component. We do not need to change anything in the attenuation, nor find the correct character that we need to attach the synth component to, because for now we only care about a non-spatial voice chat. When that is done, we will create the logic that is run when a media stream is disconnected from the ODIN room. Here, we simply search in the map for the given peer ID and destroy the returned component. Then we will remove it from the map. The last thing that is necessary for a simple voice chat logic without spatial audio is to actually join a room. We will call the join room function on our room handle, pass it the default 4 players ODIN server URL and our generated room token. We do not need to pass any peer user data yet and just want to react to the onError and onSuccess events. On error, we simply format the error with the corresponding function in the ODIN library and print that as a string to the log. On success, we create an audio capture, save that to an instance variable again, then construct a local media stream from that, and finally add that to a room. The events on error and on success can simply print something out so we know what happened. Finally, we will start capturing audio in the audio capture object. Now to test again, we can start with the play-in editor settings from before. Start as a listen client and start two instances of our game. They connect automatically, and we can see that with the printed strings on the screen and in the log. But when we talk in the default microphone of our Windows system, we are unable to hear the other client receiving it. To easily fix that, we will change the volume modifier of the engine for unfocused windows to 1. Close the project for this, go to the engine configuration file of your project, locate it in the config folder and search for or add this line for out of focus audio volume adjustment. Now when we restart the project and start the play-in editor mode, we can hear what the non-focus client hears from the focus client that is currently listening to our default input device. That is it for the first part. We have established an easy, free-to-use voice chat without spatial audio for up to 25 concurrent users. Next steps are to use the 3D audio engine of Unreal to make the voice chat more immersive. For this, we will also build a logic that connects each media stream to the correct player character of the game. I hope you find the state of the project useful already. With a few more steps, you can create simple additional game-specific logic, like push-to-talk or an ODIN voice chat room just specifically for radio set-like communication, either inside just a specific group of players or for all connected players. More advanced steps to a 3D spatial voice chat. If you want to reach out to us, feel free to join our Discord server or follow us on social media. The links are in the description. Have a nice rest of your day and see you then.